In this video, we will learn about wireless transmission of electricity. The first thing you need to make is the emitter coil. For this, you need a bottle that is about 1.5 inches in diameter. Then you have to take the magnet wire and make 12 turns around the bottle. After the first 12 turns, take the wire and make a twist in order to have a center tap. Then make another 12 turns. Cut the wire, and now we have a coil with 3 connecting points: the starting point, the center tap, and the end point. After you finish the coil, put some tape in order to avoid unwinding. The receiver coil is made in the same way as the emitter coil, but you don't have a center tap. It's just 24 turns of wire, and you have to connect an LED in the 2 endpoints. Here we have the diagram for the emitter coil. We are going to connect the center tap of the coil to the positive of the battery and the 2 other wires of the coil to base and collector of the 2N222 transistor. The emitter of the transistor goes to negative. And that's it. Okay, we are ready to test our system. Here's the emitter coil, receiver coil, AA battery. Here we have this coil connected to the meter, and notice that if we take a magnet and move it through the coil, a current is induced. This is Faraday induction law. But notice that if we take the magnet inside the coil without moving it, no current is induced. That is, the magnetic field must be moving in order for a current to be induced in the coil. When we connect the battery to the circuit, a current circulates through the coil and a magnetic field is formed. When the battery is disconnected, the magnetic field collapses. The function of the transistor is to connect and disconnect the battery thousands of times per second. Therefore, we have a magnetic field that is created and collapses continually. So we have a variable magnetic field. This variation induces a current in the receiver coil, and this current is what powers our LED. Transformers work in a similar way. We also have 2 coils. We have a primary coil and a secondary coil, but the fundamental difference is that in a transformer we have a core that is made of iron or ferrite, and the function of the core is to make the magnetic field to be concentrated in the region where we have the coils. We can have different number of turns in the primary and the secondary, but Here we don't have a core. We cannot have an arbitrary number of turns in the coils. They must be designed with a certain number of turns and a certain diameter and form so that they form a resonant circuit. When the coils are in resonance, the transference of energy between them is at a maximum point, so we don't need the core. This is known as resonant inductive coupling.